You know, there's a silent war raging in the digital world, and it's been going on for years. On one side, you've got governments and law enforcement who want, and they say need, access to our communications. On the other side, a movement that's pushing for absolute, total digital privacy, a world where our conversations vanish without a trace. Well, a new player just hit the field. It's called the Mycelia-Project, and trust me, it's not just another encrypted app. This thing is designed from the ground up to completely erase the digital evidence trail.
And this right here is the heart of the conflict. On the left, you've got this idea of the transparent citizen. In German, der gläserne Bürger, the belief that for society to be safe, authorities need a window into our lives. But on the right, you have the reality of going dark, where powerful encryption is making our digital world completely opaque, completely invisible to investigators. It's a fundamental battle between total access and total silence.
So here's what we're going to do. We're going to pull back the curtain on this Mycelia project. We'll start by looking at this war over digital silence. And then we're diving deep into the three core secrets of its architecture: the ghost server, the GPU hideout, and what they call the randomness universe. And finally, we're going to ask the really big question: have they actually built an unbreakable fortress?
Okay, so before we can really get why Mycelia is such a huge deal, we have to talk about why the apps we use every day, even the ones that claim to be super secure, are, well, kind of broken when it comes to real privacy.
Think about an app like WhatsApp. Yeah, the message itself is encrypted, but the app is leaking metadata all over the place. Authorities can easily see who you talk to, when you talk to them, and for how long. And a lot of the time, that's more than enough to build a case. Then you've got services like EncroChat, which got completely dismantled because law enforcement found and cracked their central servers. That one weak spot, that single point of failure, brought the whole network down. Mycelia was built specifically to eliminate these two problems.
So how does Mycelia solve this? Well, its first big secret is what they call the ghost server. It's an architecture designed to be a complete and total dead end for any investigation. It's literally a server that has nothing to say. The whole concept is called a dumb relay. And I want you to picture a postal worker who's blind, deaf, and has severe short-term memory loss. That's this server. There's no database, no user accounts, no names, no phone numbers, nothing. It sees a blob of encrypted data, passes it along, and instantly forgets it ever saw it. The message only exists in its memory for milliseconds. The source code itself describes it as having a Zen Buddhist-like emptiness.
And here it is. This is what it actually looks like running. It's just a tiny script listening for connections. That's it. If the authorities raid the building and seize this machine, what do they find? Absolutely nothing. No logs, no user data, no message history. You can't hand over information you never had in the first place. It's plausible deniability baked right into the code.
All right, hang on, because this next part, this is where things get really wild. This is the secret that takes Mycelia from just being a secure app to being an absolute forensic nightmare. It hides its most important secrets in the last place anyone would ever think to look.
So think about this for a second. Let's say your phone gets seized and it's unlocked. Forensic tools can literally scan the phone's memory, find the encryption keys, and read all your messages. So how do you stop that? How do you make the entire process of encryption just disappear?
Mycelia's answer to this is just radical. See, every other app you use does all its security work on the main brain of your phone, the CPU. The keys are stored in the main system memory, the RAM. But Mycelia, nah. It shoves the entire operation, the keys, the encryption, everything, over to the graphics processing unit, the GPU. It hides it all in the graphics card's own special memory, the VRAM.
And why is this so genius? Well, first off, all the big forensic tools out there like Cellebrite and Axiom, they're built to scan CPU memory. They just aren't designed to go poking around in the weird, messy, hardware-specific world of a phone's GPU. Plus, the keys aren't just sitting there in a neat little file. They're buried in all the digital noise of everything your screen is drawing. The encryption itself is actually done by a tiny little program, a compute shader, that runs right on the graphics card in a space that was designed to render explosions in a video game, not to secure state secrets.
But it gets even deeper. This brings us to the third secret, and this one is almost philosophical. It's built on a level of paranoia that is just off the charts. It's a fundamental distrust of the very piece of hardware the app is running on.
You know, all of the encryption in the world, everything, boils down to one simple thing: true randomness. If the random numbers you use to create your keys are predictable, your security is completely worthless. And here's the scary part.
We have documented proof that intelligence agencies like the NSA have deliberately created and promoted weakened standards for hardware random number generators, basically creating backdoors. So if you trust the chip in your phone, you're also trusting the company that made it and any government they might be partnered with.
Mycelia's solution is just completely next level. It's called sovereign entropy. It basically says, I don't trust the phone's hardware, so I'll make my own randomness. And how does it do that? It runs a complex physics simulation on the GPU. It literally creates its own little universe, complete with its own rules for energy, pressure, gravity, and magnetism. It generates true randomness from the beautiful, chaotic patterns of this simulated reality. It gives birth to an entire universe just to create a random number it can actually trust.
And this quote from the developers, it just says it all. We trust no one, not even the hardware we are running on. That's not just a design choice, that's a political manifesto written in code.
Okay, so let's put it all together. You take the ghost server, you add the GPU hideout, and you top it off with a private universe for randomness, and you start to get something that looks a whole lot like a truly unbreakable digital fortress. But here's the thing. This fortress puts a huge amount of responsibility back on you, the user.
Now let's look at sending files. You can send anything. Text, images, documents, you name it. The file's content is perfectly encrypted, and the other person can open it directly using whatever app they need. But look closely here. The file name is sent in plain text. And that's not a mistake. It's a very deliberate choice, and it gets to the very core of Mycelia's philosophy. And that's the whole point, right? This isn't an app that holds your hand. It's a tool for professionals who understand operational security, OpSec. By leaving that file name exposed, the tool forces you to be disciplined. You don't send a critical file called secretinvasionplans.pdf. You call it receipt003.dat. The app provides the most secure lock in the world, but it expects you to have the common sense not to write the combination on the front of the safe.
So all of this combines to create what the developers call a technological vacuum for surveillance. An investigator asks the server operator for chat logs. Sorry, we don't store them. They ask for a list of users. Nope, we don't have user accounts. They monitor the network traffic. It's just unreadable, encrypted noise. They seize an unlocked phone. The secrets are buried in the GPU where our tools can't find them. The system is engineered from top to bottom to provide no answers.
What we're looking at here is a technology that effectively turns digital communication into a black box. It creates a level of privacy that is just so far beyond what's available anywhere else. And that leaves us with a really big, kind of scary question. If and when this kind of absolute digital privacy becomes the new normal, are we, as a society, even remotely prepared for that?